Generating and modulating more generating sensors produce signals output from energy taken directly from the measurement. This is very important point. So the generating sensors, they produce signals output. Let's put in few brackets. Produce signals from energy taken directly from the measurement. As an example for this, the photovoltaic cells that produces output voltage related to its radiation. The modulating sensors, they use the measurement to alter the flow of energy from an external source in a way that affects the output of the sensor. For example, the photovoltaic cells, conductive, sorry. So we have a question here. For example, compare between generating and modulating sensors. Analog and digital modes, analog signals are continuous and able to take on any value within dynamic range. So this is the uh, analog signals. Digital signals are discrete and only able to take a finite number of different values. By using ADC, this signal is changed into a digital signals, which depends on the type of ADC. For example, 8-bit ADC, the signal will be 0, for example, 0, 1, 0, 1, 1, 1, 0, 1. This is an 8-bit code resulted from 8-bit analog digital converter. Real-time versus delayed time modes. Sensor must acquire signals in real time. As the signal actually occur, the output of the system may not display the results immediately due to types of signal processing. Often such short delays are acceptable unless urgent feedback is required. Real time is required in some signals. For example, in bioelectric signals like the ECG, delay is not required. So real time is very important. The systems that record the ECG are required to display the signal in real time with minimal delay. But for example, in biochemical, the lab tests may take 1, 2, or 3 hours, or sometimes may take 2 or 3 days. This is accepted as uh, real time is not applicable in such test. The magical constraints parameters measurement ranges are quite low in microvolts and bioelectric signals like the EEG. Inaccessible crucial variables, damage system, direct measurements. The quantities vary with time, like the EEG. It's varying with time, with type of medication, uh, with different conditions. Medical measurements are widely among normal patients, even as similar conditions widely variable. For example, the blood pressure is not um, fixed or is not constant between human races. To cope with this variability, we need to assume empirical statistics and deterministic distribution functions. Safe levels of various types of energy, X-ray or ultrasound, are difficult to establish because mechanisms of tissue damage are not well understood, but there are regulations They are safety uh, laws and safety rules should be followed, and they are followed in capital devices, especially with X-ray, as it's an ionizing radiation. So when designing a system or a clinic, the safety regulations should be followed. Equipment must be reliable, easy to operate, and capable of withstanding physical abuse and exposure to corrosive chemicals. They should be reliable with time, should be accurate and precise, easy to operate. Yes, medical devices needs operator training, but not so should be not so complicated. Capable of withstanding physical abuse and exposure to corrosive chemicals in the hospital environment, like the sterilization, fluids, and other types of chemical materials. Electronic equipment must be designed to minimize electric shock hazards. Both the uh, medical staff, healthcare staff, and the patients should be safe. So the medical device amendments in 1976 and Safety Medical Devices Act in 1990 amend the Federal Food, Drug and Cosmetics Act to provide the safety and effectiveness of medical devices intended for the human use. And these acts and laws are always developing day by day in order to ensure the safety, effectiveness, and reliability of medical devices. Classification of biomedical instruments. The biomedical instruments are classified in or fall in four categories according to the quantity they sensed, pressure, flow, temperature, current, concentration. Second point, principle of transduction, resistive, inductive, capacitive, ultrasonic, or petrochemical. Third, we have the organ system, cardiovascular, pulmonary, nervous, endocrine, gastrointestinal, or the fourth classification with its wider classification according to the clinical medicine specialty, pediatric, obstetrics, cardiology, radiology, neurology, and examples of blood instruments like blood pressure meters, pH, flow, cell counter, uh, blood pressure meter, the digital one, not the traditional one that uses mercury. Heart instruments, ECG, pacemaker. This is the artificial pacemaker. The natural pacemaker is the SA and AV nodes in the heart. Defibrillator, heart lung machine, HLM. Also, baseline monitor, stethoscope, the electronic one, and phonocardiograph, and other devices. The brain instruments, EEG, tomograph, and for the muscle instruments, EMG and muscle stimulator. Uh, Also, it's not only there's a transcranial simulator also, TMG. Kidney instruments, dialysis, lithotripsy. For the air, it's bioacoustic, audiometer, and hearing aids. Lung instruments, pyrometer, or maybe you can add here the ventilators, oculomotors, aids for blind and eye instruments. Uh, for the body instruments, ultrasonography, ultrasound test, thermograph, radiograph, like the X-ray, EPF, endoscope, the physiotherapy, instruments, diathermy, shortwave, microwave, UV lamp. These are medical instruments heat used for heat therapy. Either hot heat therapy can be either hot or cold heat therapy. Electro sleeper and the massage type vibrator. Interfering and modifying inputs. Desired input. This is the first point. The desired input is the measurement that the instrument is designed to isolate. So this is the target signal that we are trying to measure. Second point is interfering output quantities that inadvertently affect the instrument and be considered as the noise. Number three, modifying input and desired quantities that indirectly affect the output and performance of the instrument. For example, here, this is the patient. We are adding two electrodes in order to measure uh, uh, the ECG signal. So we have one electrode here and second one at this point, and we are measuring the VECG by using a differential amplifier. So the desired input, this number one, will be VECG. Number two, the interfering input 60 Hz, or here in Iraq it's 50 Hz noise AC from AC lines. And we have the number three, we have the magnetic field in series with the desired modifying input, plane of the patient's cable, if parallel or perpendicular, it depends. So we have different types of noise that will accompany the desired input or the measurement, which is the VECG. This can be reduced by using several techniques, and they will be covered in details in the upcoming chapters. So the effects of interfering or modifying inputs can be reduced or eliminated by altering the design or adding component to the original system. For example, the inherent insensitivity, all instruments components have inherently sensitivity only to the desired input. So the components should be designed in order to be sensitive only to the signals that we are planning to measure or to the measurement. Negative feedback, making the output less dependent on the transfer function. For example, as you stated before, the output is the amplifier. There will be a feedback lines between the output to the input is the output. This is the negative feedback, or sometimes it's capacitor or compound between both of them. So takes a portion from the output and feeds it back to the input. The output dependent signal is subtracted from input, and the difference is the effective input. Here with negative feedback, the system gain is more stable and can be determined. Signal filtering, the input signals block interfering and modifying inputs without input filter, sorry, will block the interfering and modifying inputs without altering the signal. Different types of filters can be used, like the high pass filter, low pass, or band stop filters. Different kind of filters can be used with the signal. The opposing inputs, additional interfering inputs can be used to cancel undesired output components. The basic objectives of the instruments: information gathering, measure variable for knowledge, characteristic of the measurements may not be known in advance. Diagnosis: measurements are made to help in detection and the correction of some malfunctions in the system being measured. Evaluation: measurement used to determine the ability of the system to meet its functional requirements. Very important because made to measure a specific signal. Monitoring: measure of process in order to obtain continuous or periodic information about the state of the system being measured and control the operation of a system based on change in one or more of the internal. These are the prefix. You should all know the scientific notation according to the SI units, the physical constants and units like uh, Planck's constant, the voltage and mass of an electron, velocity of electromagnetic wave, the pi. These constants, physical constants and mathematical constants, uh, they will be given for you in the exam. No need to memorize all these constants. For the logarithmic representation of signal levels in decibel, decibel means of logarithmically expressing the ratio between two levels. For example, in order to um, represent the gain in dP, the voltage gain equals the output voltage divided by the input voltage. If the Vn was zero point 0.5 volts and V out was 6 volts, then the voltage gain will equals V out divided by Vn equals 6 volts divided by zero point 0.5 volts, so the gain will be 12. That's a unitless parameter. In dB, it will be expressed as 20 log V out divided by Vn. 20 log 12 equals 21.6. This is what the voltage. For the current, it will be the same way. So 20 log the output current divided by the output current. But in power, in dB, it equals 100 P out divided by P in. This is proportional to the square of the voltage current. The converting Vp to voltage, V out into voltage not in dB, V in 100 dB divided by 20. So this is the second part of the chapter 1, and I hope in the next time we will meet again in the classroom or in online meeting, an active online meeting. And if you have any questions, you can send the questions via students platform, and all your questions are welcome. Thank you for your time.